Hi there, folks. This is the practice for the final, and as always, I am the amazing Mr. Jansen, so away we go. If we take a look at this first one, we're multiplying these two things. Remember, when we're multiplying rational expressions, we want to reduce everything as far as we can first, so I have to factor everything completely. In this numerator, I can factor out a 3, which leaves me with a 2x plus 3. The denominator, I build a bridge, and I factor. This is going to factor into an x minus 5 and an x plus 2. Over here, the numerator is going to factor into an x minus 5 and an x plus 1. The denominator you might have to take off to the side, but this is a 2x squared plus x minus 3. Remember when we do this, two numbers that multiply together to give me a negative 6, but add together to give me a positive 1. It's going to be a positive 3 and a negative 2. And many of you are probably going to do it this way. You're going to split up the middle term and factor by grouping. So that's fine, 2x squared plus 3x minus 2x minus 3. Group the first two together, group the second two together. Out of the first two, we can factor out an x, which leaves me with a 2x plus 3. Out of the second two, I can factor out a negative 1, which leaves me with a 2x plus 3. And so now my two factors coming back over here are the 2x plus 3 and the x minus 1. Okay, so now I cancel out everything that I can. The 2x plus 3's cancel. The x minus 5's cancel. And that looks like about it. That's all that's going to cancel out here. So now in my numerator, I'm left with a 3x plus 1. In the denominator, I'm left with an x plus 2 and an x minus 1. And that's it. Okay. Factor, cancel out any common factors, and then multiply straight across. Number 2 is very similar to this, except we have one extra step. The first thing we do is we change division to multiplying by the reciprocal. So the first fraction stays the same, but the second fraction, I'm going to change this to multiplying, and I'm just going to flip this second fraction. And now it becomes a multiplication problem, which is exactly what we just did. Okay, so I'm going to do that same process over again. I factor everything completely. So here I can factor out a 4, leaves me the 2x plus 1. Again, down here, I would probably take this off to the side. But when I do, I'm going to find out, let's see that that's going to factor into a 2x plus 1 and an x plus 4. Okay? Over here, this is going to be an x plus 4 and an x plus 4. The denominator, this is a difference of squares, so that's x plus 4 and x minus 4. And now I cancel out what I can, the 2x plus 1s, a pair of the x plus 4s, another pair of x plus 4s. And now in my numerator, it looks like I'm left with a 4. In the denominator, I'm left with an x minus 4, and that's it. Number 3, when we're adding these things together, we have to get common denominators. So if I need common denominators here, the first thing I'm going to do is I'm going to factor each denominator. Okay, when I do this, this one's a difference of squares, x plus 3 and x minus 3. Basically, this will help to show me what my common denominator is going to be. This one's going to factor into an x minus 4 and an x minus 3. And remember, what we have to do here is we have to make sure each denominator has the same thing. So right now, the first denominator has an x plus 3 and an x minus 3. But when he looks at the second denominator, he doesn't have an x minus 4. So we're going to give him an x minus 4. Okay? He wants what the other denominator has. And now this first denominator has those three pieces, x minus 4, x plus 3, and an x minus 3. The second denominator only has two of those pieces. It's missing the x plus 3. So we've got to give him an x plus 3. All right. Again, when we do this, we're multiplying, and we have to multiply the numerator by the same thing as the denominator. We have to multiply by a form of 1. So now in my numerator, I'm going to multiply these out, which means I have to FOIL or distribute. So that's going to give me an x squared minus 6x plus 8. The denominator I'm just going to leave in factored form, the x minus 4x plus 3x minus 3. Over here again, I FOIL, that's x squared plus 7x plus 12. The denominator I'm going to leave in factored form once again. And now this is addition, so I combine like terms. I add up the numerator. That's going to be a 2x squared plus x plus 20 all over an x minus 4, x plus 3, x minus 3. Okay? And the last thing I do is I check to see if this numerator is going to factor to see if I can reduce anything, but it doesn't look like it's going to. So that's it. Number 4, we want to find these values and graph this thing. And the first thing we want to do is the domain. Remember, we're looking for our domain restrictions. Remember, with a fraction, we can't have a 0 in the denominator. In other words, x squared minus 1 cannot equal 0. So now I'm just going to solve this, and I can solve by factoring. That's x plus 1 and x minus 1 can equal 0. And I set each of these equal to 0, so I find out that x cannot equal a negative 1 and x cannot equal a positive 1. So my domain restrictions are that x cannot equal plus or minus 1. Okay? So that's my domain. For vertical asymptotes, really I'm going to do vertical asymptotes and holes in the graph at the same time. Because these come from my domain restrictions, I'm going to have to factor this thing and see what cancels out first. So in the numerator, I'm going to factor this numerator again. I build a bridge. That gives me a negative 10. The two numbers are a negative 5 and a positive 2. And most of you are going to have to take that off to the side, split up the middle term. And you're going to find out when you factor this thing, you're going to get a 2x minus 5, and you're going to get an x plus 1. My denominator I already factored once was an x plus 1 and an x minus 1. And now we just reduce this thing. The x plus 1's cancel. So the reduced form of this fraction is 2x minus 5 over an x minus 1. Okay? And now we look at our domain restrictions. We look at the factors that they came from. And whatever got canceled out, the factor that got canceled out, that domain restriction is my hole in the graph. The other one is the vertical asymptote. And if we look right here, the x plus 1 is the thing that got canceled out. And the x plus 1 gave me the domain restriction x equals a negative 1. So x cannot equal negative 1 is the restriction that got canceled out. So that's my hole in the graph is negative 1. And that's just the x value for the hole in the graph. Okay? The factor that's still there, the x minus 1, that gave me the x cannot equal a positive 1. That's my vertical asymptote. So I say x equals 1. It's the equation of a vertical line. Okay? To finish getting my hole in the graph, I'm going to plug that x value into this simplified form of the function. So I'm going to bring that down here and do that. So let's see, that's a 2 times negative 1 minus 5 all over negative 1 minus 1. So it's going to be a negative 2 minus 5 over a negative 2, which is a negative 7 over a negative 2, which is a positive 7/2. Or since we're going to be graphing this, I guess I should just call it a 3.5. Okay? And now from here, we go back and find our oblique or horizontal asymptotes. We're going to have one of these, but not the other. And for this, we look at the degrees of the numerator and denominator. The degree of the numerator is 2. Remember, it's the highest exponent term. The degree of the denominator is also 2. When the degrees are the same, it means I have a horizontal asymptote, and I divide the leading coefficients. So here, the 2 divided by the 1 that's out front. So that would give me y equals 2. If the degrees are not the same, if the denominator has a larger degree, it's horizontal and it's y equals 0. If the degree of the numerator is larger, then I have to use synthetic division, and that's where I have an oblique asymptote. So this one, there is no oblique asymptote. It's only a horizontal asymptote. And now I'm going to graph this thing. So when I graph it, I'm going to start with the asymptotes, the x equals 1. And remember, for the asymptotes, I use a dotted line because these are just here to guide me. Y equals 2 is right here. And now if I want to find out where this thing is, I have to plot a value on each side of the vertical asymptote. So I'm just going to do a quick XY chart. I'm going to choose some values on each side. So I'm going to choose probably a 0 and maybe a 2. And again, it's easier to plug it into the simplified form. When I plug a 0 in, I get a 5 out. When I plug a 2 in, let's see, that's going to be 4 minus, that's a negative 1 over a positive 1. That's going to be a negative 1. So now if I plot these points, 0, 5, 1, 2, 3, 4, 5 is right here. 2, negative 1 is right here. I also have my hole in the graph that I can plot at negative 1, 3.5. So negative 1, 3.5 is right here. That's my hole in the graph, and I know that it's going to hug this line, go through these points, and hug the other line. It's going to do the same thing here. It's going to hug this line, go through the points, and hug the other line, and that's my graph. Okay, so again, the graph includes a couple values that we had to plot, includes the vertical and horizontal asymptotes, and it's got to include that hole in the graph. Okay. Number 5, it says decide if the sequence is arithmetic or geometric and find the next two terms. So really we're just looking for the pattern here. In this one, it looks like I'm subtracting 6 each time. So if it's going down by the same value, I'm adding a -6 each time. That means this thing is arithmetic. So this one is arithmetic. And if I want to find the next two terms, I just subtract 6 again. That gives me a 32. I subtract 6 again. That gives me a 26. And that's it. Okay, so it's arithmetic. And those are the next two terms. For the next one, we want to decide the same thing, and really it looks like I'm dividing by 2 each time here. So really I'm multiplying by 1/2 each time. And since I'm multiplying by the same thing each time, it means this one is geometric. And if I want to find the next two terms, I'll just multiply by 1/2 again. That's going to give me a 3/2 and then a 3/4. And that's it. Those are my next two terms. Okay? For these, it says use the following formulas to answer the questions. So we're just going to have to decide which formula we're going to use and plug the stuff in. Number 7, it says find the 13th term of the sequence, given a sub 1 is 7 and d equals 3. And really, since they give us a d value, I know we're talking about an arithmetic. And we're not talking about a sum, so I just want my plain arithmetic sequence formula, which is this first one. So I'm going to do a sub 13, because I'm looking for the 13th term, equals a sub 1, which is 7. Plus n, which is 13, it's the number of the term I'm looking for, times d, which is 3. And I just have to simplify this. That's 7 plus 12 times 3. So that's going to be a 7 plus 36. So I find out that the 13th term looks like it's going to be a 33. Sorry, a 43. Let me try that one more time. 43. There we go. And that's it. On this one, it says S sub n, so right away I know I'm looking for a sum. They also give me a d value, which means this thing is arithmetic. So I know I'm using this second formula. That's my sum of an arithmetic series. So S sub n, so I'm looking for S sub 20 equals 20 over n, which is, over 2 from our formula. And then a sub 1, which is 7 plus a sub n, but I don't have a sub n. They didn't give me that, which means I need my other arithmetic formula. So I'm looking for a sub 20 this time. A sub 1 is the 7 plus n minus 1 times d, which again is the 3. Okay, so now I've got to plug this in. Once I find this, I'll have my a sub n, which will go here. So now I've got to plug this in. That's 7 plus, that's going to be 19 times 3, so a sub 20 equals 7 plus, let's see, that's going to be a 57. So this is going to give me a 64. So now I'm just going to plug this into my calculator. I've got 20 equals 10 times. 7 plus the 64 is going to give me a 71. And now when I multiply, that gives me 710. And that's it. All right, so if you're missing a piece from the formula, you might have to go use another formula. All right.